Hello everyone. In this lab, we will investigate the effect of clay and water-soluble polymers on API filtration loss characteristics of water-based drilling fluids. In the experiment, we will measure the static filtration loss using a standard API filter press. We will observe how the filtration loss changes with time and also measure the filter cake thickness. We will also learn about methods that are used in the field to control filtrate loss. One of the key functions of drilling fluid is to control filtration loss. The characteristics of filtration loss in drilling fluid include minimizing the loss of fluid to the formation and maintaining borehole stability. Controlling filtration loss is important for many reasons. First of all, the filtrate lost to the formation must be balanced at the surface in order to maintain the desired mud volume. Second, the filtrate lost to the formation will affect the logs obtained after the hole is drilled. For example, the filtrate can flush hydrocarbons from the rock, changing the in situ saturations and changing the resistivity of the formation water near the wellbore. Third, the filtrate lost to the formation can react with clays in the formation rock and cause irreversible formation damage near the wellbore. Lastly, the filtrate lost to the formation leaves the solid portion of the mud behind, deposited on the wall of the hole. This deposit can become sufficiently thick to stick to the drill string or casing. There are two forms of filtration loss, static and dynamic, also known as spurt loss and continual loss respectively. Continuous loss of the liquid phase in drilling fluid to a permeable formation is due to a positive differential pressure between the fluid pressure in the wellbore and the formation pressure. Filter cake is a factor that contributes to filtration loss. This is the formation of solids deposited at the wall of the wellbore. Spurt loss is caused from the bridging of pores by solids contained in the drilling fluid and by non-uniform cake deposition, and uniform cake deposition contributes to continual loss. Filtration loss has many implications. First of all, drilling rate increases as spurt loss increases. Secondly, wellbore instability increases as the fluid loss increases, particularly in active shale formations. Third, thick mud cakes enhance the chances of differential pipe sticking. Fourth, thick mud cake increases the chances of swabbing, which may induce kick. And formation damage in pay zone increases as fluid loss increases. There are 5 main factors that contribute to the volume of filtration loss. 1. Time in open hole. 2. Differential pressure. 3. Solids in mud. 4. Mud cake permeability. 5. Filtrate viscosity. Flow of mud filtrate through mud cake is modeled using Darcy's law, seen on screen right now, where V subscript F represents volume of filtration loss, T represents the time, K represents cake permeability, H subscript MC represents cake thickness, mu represents filtrate viscosity, and delta P is the differential pressure. There are 2 main tests used to measure static filtration. In this lab, we will use the standard API filtration loss test. The test is conducted using a standard filter press, which has a circular cross-sectional area of 45.8 centimeters squared. This test measures the volume of filtrate collected in 30 minutes under the application of 100 psi. Volume collected is modeled in a linear relationship where the filtrate that flows through the filter cake is proportional to the square root of time, and the spurt loss is the initial recorded amount of filtrate volume. In the equation seen here, V30 is filtrate volume after 30 minutes, V7.5 is filtrate volume after 7.5 minutes, and VSP is the spurt filtrate volume. Through the use of these equations, abbreviated tests can be done to find 30-minute filtrate volume in an alternative way. The relationship between pressure and filtrate volume is not as well defined as the relationship between volume and time. However, the relationship is proportional to the pressure raised to some power. Several different additives are used to control filtration loss, including bentonite, starch, and other polymers. In this experiment, we will be using bentonite, sepiolite, and two biopolymers commercially known as Quictrol and Barafos. In this experiment, we will prepare and test 6 different mud samples which are listed under step 1A to F. Let's start with making the mud samples. In this video, all mud samples are based on 350 cc's of water. The first step is to weigh the clay and the water. When using the mud mixer, slowly combine the bentonite and water in the cup. Do not pour both in all at once, or else the mixture will not be homogeneous. As it begins to mix, continue adding the water and additive in small portions, a bit at a time. The next step is to turn on the pressure tank and measure the filtrate volume over time of the samples at 100 pounds per square inch of pressure. After the filtration test, which lasts for 30 minutes, measure the mud cake thickness of all samples. The thickness must be reported to the accuracy of 30 seconds of an inch. Make more than one reading and average the values. Repeat this procedure for samples A to E. For the last test, create another sample the same as described in step 1E. However, this time around, measure the filtrate volume at 50 psig and also measure the mud cake thickness. In the lab report, plot the filtrate volume of the first 5 samples on the same graph paper. Prepare 2 plots, one with filtration volume versus time, and the other one with filtration loss versus the square root of time. In the second part of the lab report, calculate the spurt loss using filtrate volume measured at 7.5 minutes and 30 minutes. Also, determine the API water loss and mud cake thickness for each sample and display the results in a table. The third part of the lab report is to establish the difference between the effectiveness of the filtration control additives used in this lab. The last part of this lab is to determine the pressure-volume relationship by calculating the correlation coefficient of the Barafos mud system. Explain how the value for the correlation coefficient was obtained, and explain the physical significance of this value. This concludes Lab 2. In this video, we have presented the theory and also discussed the importance of controlling drilling fluid filtration loss. Using 6 different samples, we have investigated how using different fluid loss control additives and how their concentration influenced the API filtration loss.